Hi Deepa, can you hear me? Okay. Okay. Let us start the session. First, let me recollect whatever we have discussed in the previous sessions, and then we will continue. Okay. So when we start the previous sessions, from last two sessions, we have discussed about the concepts of software testing. Concepts of testing, like what is software testing, what are the different types of testings and all, and different levels like levels of testing and types of testing. Right, so all these things we have discussed in the previous sessions. Now today we will focus on mostly process related stuff, like in the real time how the testing process will be. This is basically called as STLC, software testing life cycle. So this is process oriented. So far what we discussed is what is testing. Okay, so now we are going to discuss about what is the process, like how where the testing will start and what are the activities we are going to perform and what are the different phases we have. So what are the roles and responsibilities? So all these things we will discuss. So that is a part of STLC. So STLC means software testing life cycle. Software testing life cycle. So we have already discussed about SDLC, right, in the previous session, software development life cycle. So software development life cycle says the entire process from the requirement, designing, coding, testing, maintenance, everything. All the phases will be included in the SDLC process. But SDLC is a part of the SDLC. SDLC will talk about only the testing process. Okay, within the testing environment, what is the process we need to follow? Where we need to start our testing, like requirement understanding or test planning, test cases, test designing, and test execution, defect reporting. All these things comes under the SDLC, software testing life cycle. So SDLC is the overall software development life cycle. This is for entire software development. Software development life cycle. Okay, SDLC is a part of SDLC. SDLC is a sub part of SDLC. Only it is talking about the testing part. Okay, so now today we will focus on process. So far we discussed is what is testing and what are the levels, what are the types of testings and all those things. Now we are going to testing process 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 of testing. So that is talking about the SDLC. Okay, and once we understanding the process and all, then we will talk about how to test. So whatever testings we learned so far, we need to understand how to test, how to conduct those kind of testings in the application. So that's the next phase. So now let us talk about the STLs. So before going to software testing lifecycle, we have more number of phases here, like requirement understanding will start, and then test planning, how to plan your test, then how to prepare your test cases, how to execute your test cases, and how to identify the defects and how to report the defects and all. So these are all comes under the STLC, software testing lifecycle. Now before going to STLC, we will need to understand few testing terminologies. Testing terminologies. So far we have discussed about few types of testing like functional, non-functional, and within the functional again we have n number of testings, and non-functional also we have n number of testings. Along with those testings, in the regular in day-to-day life, or when you're working in the real time and day-to-day life, we will use some terminologies. Those are specifically for testing. So we need to understand those terminologies first. So before going to process. So terminologies. So let me discuss them first. So what are those testing terminologies? So like sanity testing or regression testing, retesting, okay, ad hoc testing, exploratory testing. So these are all different kind of terminologies. Okay. So before going to discuss about STLC, let us understand what are all terminologies we have. So these are all process related. As I said, these are all process related, right? So now let me share a presentation. So testing terminology. So these are the concepts we are going to discuss for testing terminology and STLC process. So ad hoc testing and monkey testing. So first terminology is ad hoc testing. So this name is very frequently we hear in the real time environment. Ad hoc testing. What is ad hoc testing? What is monkey testing? So very simple. I'll give you a few examples, then you can easily understand instead of reading all these things. Ad hoc testing means very simple. Suppose if you have a application in your hand, if you have an application and you don't have, suppose you have an application to be tested. See, this is application under test. So application is ready. If you want to test this application, okay, if you want to test this application, so what is the prerequisite? You should have some test cases. Okay, you should have some test cases, and then you should know the functionality of the application. You should have the test case by hand, and also you need to understand the functionality. So these are the prerequisite to test the application, right? But in ad hoc and monkey testing, the both the testing, you will perform randomly testing application. That's called random testing. So this word is important. It tests the functionality of the application randomly, because here we don't have any documentation. That means we don't have any test case. We don't have any test case. Okay, so this we don't have any document, but we have an application ready, and without having any documentation, we will test the functionality randomly. Okay, so that is basically called as ad hoc testing. Okay, so based upon our knowledge, we know little bit functionality based upon our previous experience and previous projects. Okay, so suppose if this is general application like banking application, what are the common functionalities we have in the banking, like adding customer, deleting customer, or sending funds? All these things will be there, right? Any banking application having the same thing, but the UI or flows or navigations will be changed. So based upon your previous experience and based upon your projects, and we can test our application ad hoc. So ad hoc testing. So randomly test this application without having any documentation part. So that is basically called as ad hoc testing. So here we know the application knowledge. We know the little bit functionality of that application. So by knowing the functionality, so we'll do ad hoc testing. So that is basically called as ad hoc testing. Randomly test the application. Yes, exactly. So if suppose if any websites are launches, we don't know exactly how we need to work it, but we will explore our knowledge by checking all these things, right? That is basically ad hoc testing. Okay, so based upon your previous experience, we'll explore our application knowledge. So that is all about the ad hoc testing. So randomly testing the functionality. There is no test case, there is no proper order. Okay, there is no particular time, nothing will be there. Just open application and randomly test all the functionalities. So that is all about the ad hoc testing. And monkey testing is also exactly the same, but a small difference with there. In ad hoc testing, we will test the application randomly, right? But is a monkey testing is also a random kind of testing. But here the monkey testing and ad hoc testing a little bit difference is there. In ad hoc testing, we know a little bit the functionality. Okay, but in the monkey testing, we don't know any functionality of that application. We don't know any functionality of the application. So especially for the gaming applications, what we need to do is, so children will play the games, right? So they don't know how to operate the games. So but randomly they don't know, without knowing anything, they'll click something. So they'll operate unexpected manner. So in that case also, application should not be broken. So that is a case called, that is the main example. That is the example of the monkey testing. So gaming, testing game and applications are comes under the monkey testing. So without having any documentation or without having any knowledge of that application, randomly test the functionality. So that is basically called as a ad hoc testing as well as monkey testing. A small difference between these two are ad hoc testing. We know we know little bit functionality of that application. But when you come to the monkey testing, we don't know any prior knowledge of the application. So randomly by pressing all the keys, what is happening? What is unexpected? Is the application is broken or not? So those things we will test. So that is a part of monkey testing. Okay. So both are almost 90% exactly the same. A small difference will be there. So that's the reason people will ask, what is the difference between ad hoc testing and monkey testing? Or similarly, retesting and regression testing. Both are seems very similar, but there is a small difference. So like that, there are some combination of testings will be there. I am going to discuss them. So first one is ad hoc testing and monkey testing. So randomly test the functionality by knowing the functionality, that is ad hoc testing. So say monkey testing, randomly test that application but without knowing the functionality, that is monkey testing. Okay, so these are the two tests. For both the testing we don't have any test cases and nothing. This is just like a random testing. Okay, now the next one is retesting and the regression testing. These are the very important. So retesting means testing the application with multiple inputs. So for example, let us say a login screen we have. So if you want to test this is a login case, right? So we need to provide multiple kinds of input, like a valid input, valid username and valid password, and invalid username and invalid password. Invalid password and invalid username and the valid password, and valid password and invalid user password, and some blanks. So all these test data we require. So we are having only one test case, entering the username, entering the password, and click on the OK button. But inputs are different. So we are testing the same thing again and again, but we are using different kinds of inputs. So this is basically called as a retesting. Okay, executing the same test case again and again by using multiple inputs. So that is called as a retesting. And regression testing means here we also execute the same test case again and again, but with not multiple inputs. So every build, like for example in the testing department we have and developer we have. So every time, so developer will send the new build to the testing team, multiple versions of the new build. Suppose I have 10 test cases I have in my hand. The first build I have verified all the test cases, but some test case has been failed. Suppose 8th or some test case has been failed. I have reported the defect to the developer, and again he has given one more build called version number 2. And in the version number 2, what are the test cases I need to execute? Suppose let us say 8th test case have been failed. I have reported as a defect. Then he fixed it and he has given one more build. So the first priority will be the test case. 8th test case I have been failed, that I will verify, re-verify. So that is fine. That is working fine. But that is not only enough. Because of that fix, there may be some other test cases also will impact. Some other functionalities also will impact. So what we need to do is we need to make sure because of this fix, other functionality should not be broken. Okay, so that is the base called as a regression testing. So we need to also execute the whatever test cases have been passed in the earlier builds. Okay, so here this is a basic challenge in the manual testing because we need to do the retesting and regression testing many times. So if you want to do manual testing here, a lot of effort and time is required. So that's the reason automation tools comes into the picture. Okay, especially for retesting and regression testing. All right. So this is the retesting. So retesting is testing the fixes for every build, and because of those fix, there should not be any side impact on the application. Because of that fix, there should not be any side impact, or there should not be any other functionality should not be broken. So that is the main intention of regression testing. So retesting and regression testing. So retesting means executing the same test case again and again with multiple inputs, and regression testing conducted on the modified builds, whether the fix is working or not. Because of the fix, there should not be any impact on other functionality. So that is basically called as regression testing. Okay. Now, next one is sanity testing and smoke testing. So almost same. Sanity testing and smoke testing. So practically there is no difference at all. Practically there is no difference at all. But theoretically a small difference we have. So sanity testing and smoke testing. Sorry, theoretically we don't have any difference, but practically there is small difference. Let me tell you what is sanity testing and smoke testing. So sanity testing is basically basic functionality testing. So both are comes under the basic functionality testing. So we have n number of names like BVT, build verification test, or TAT, tester acceptance test. Okay, so these are all comes under the sanity and smoke testing. So people will call it with the different names. So the main intention of these two testings are we need to check whether the build is stable or not. As soon as we get the build from the developer, first it should be stable. It should be installable in our environment, and basic screens should be appear, and navigation should be working. Then only we can execute our test cases, right? So the main intention of conducting these testings are the stability of the build. So we need to make sure the build is stable after installing in your environment. Sometimes some installation itself will fail. Sometimes installation will pass but basic screens will not be appear, navigation will not work. So in this case we can simply reject the build. So if sanity testing or smoke testing is failed, we will reject the build. Rejection in the sense they have to create one more build, developers has to create one more build and they have to provide that build to the testing team. So sanity testing and smoke testing is a basic functionality testing, build verification test or tester acceptance test. So why we are calling tester acceptance test? Because tester will accept the build only if sanity or smoke testing have been passed. Otherwise, tester will not be accepted. It will reject the build. That's the basic criteria. So what's the criteria here? The build should be installable successfully and the basic screen and navigation should be successfully will be working. So that's the main criteria of accepting the build. So sanity testing and smoke testing, small difference. Let me tell you one scenario here. We have a developer and we have a testers. After testing team, we have another team called as UAT team. Okay. So what developer will do is developer will develop the code and they will make the application or final integrated product. We don't get the code for testing, right? So we'll get the installer. So once they have created the code, they will make an installer like exe or some package kind of thing. And that exe they will provide us. So just we need to install it. We cannot see code whatever they have written internally. We don't see that. So the code, the application, whichever they have provided, that we need to install it. So what developers will do is before delivering this product or before delivering this application to the tester, just at the high level, once they created the build, they will test basic things like whether it is installable or not. Okay, screens or basic screens are working or not. Very basic things. Just they have only 5 to 10 test cases, very small test cases, and all are P0 test cases. P0 means high priority test cases and high severity test cases. So they have their own test cases. They are called as unit test cases. So they will test this build. So before delivering the product or before delivering the application to the testing team, they will do basic testing. So basic functionality testing. So here we are called as a smoke testing. Smoke testing. So before delivering the application to the testing team, they will do basic functionality testing. Basic functionality testing. So that is smoke testing. When they will conduct before delivering the application to the next department or next phase, that is smoke testing. Now when you come to the testing team, as soon as we get the build, what we will do again, we will conduct the basic functionality testing. And how to conduct, we will install build in our environment, and after installation is successful or not, and basic screens or navigations are working or not. So once as soon as we are getting the build from the development team, we will also conduct the basic sanity testing. So here we are calling as a sanity testing. Here we are calling as a sanity testing. So exactly the same, both are same, but only thing is small difference is here the developers are conducting smoke testing before delivering the build to the next phase. Next phase. Okay, this is a exit phase. For them, it is a exit phase. But for us, as a tester, this is the entry phase, right? At the beginning, as soon as we get the build from the developer, we are conducting the sanity testing. So this is the entry phase. That's the only difference. Okay, so smoke testing is always conducts at exit stage. So once all the testings have been done before giving the build to the next phase or next department, then we will conduct the smoke testing. And after receiving from another department, if I receive the bill, initial testing we will conduct at the beginning level, that is sanity testing. Similarly, once the sanity testing is completed, we also release the bill to the next department. There is another next phase, that is UAT phase, right? So we need to also release the bill to the next phase. Once we have completed all our functional everything, that time also we will also conduct smoke testing. Now you understand this. Sanity testing and smoke testing both we will conduct, but sanity testing we will conduct at the beginning stage. So whenever we get the build from the developer to make sure the build is stable, and at the end, before giving the build to the UAT team also, before giving just 2 hours or 3 hours before or off day, not more than that. We don't spend much time on sanity and smoke testing, not at least 2 to 3 or 4 max, not more than maximum is off day. Okay, not more than that. So before giving the bill to the next department, that is UAT team, here we will conduct again smoke testing. So here smoke testing and sanity testing conducted by anyone. There is no restriction for developer has to conduct or testing team has to conduct like that. No. Even though we are testers, we will conduct sanity at the entry phase. We will conduct smoke at the exit phase. So testing is same. To main intention of the testing is to check the build is stable or not. That's the only intention. But where and when we are performing testing, so that is an important. So the question, if we itself is doing UAT, we will not conduct smoke testers. Not required. Not required. Okay, if you are conducting UAT, sometimes testers itself will conduct UAT testing. So at that time, not required. Okay, so the criteria is if I hand over the bill to the next phase or next department, then we will test the small thing. Okay, simple, very simple example I'll tell you. Suppose if I purchase any item or any electronic item, right? So suppose if it is a light or it's a bulb or it's a mobile, anything if you purchase, we will test there itself, right? Just we will switch on, is the power is on or off. Basic thing we will do that. And then we will purchase and come back to the home and then we will start using it. Simple. This is also same thing. Entry level testing and exit level testing. So before giving the product to the next department, we need to make sure, right? We should first install it and okay, everything is fine. Then I can provide the bill to the next phase. So that's the main criteria. If we don't have any next phase, this is our last phase, that is fine. Even UAT also, once they have conducted their testing before installing in the production, this is the last stage, right? And they also conduct the smoke testing, sanity testing. Okay, so every phase anyone can conduct sanity and smoke testing, but sanity testing is the entry level. So as soon as we get the bills, we need to re-verify it. Stability of the application we will test. So that is basically called build verification test or tester acceptance test. Tester acceptance test. Smoke test is a basically exit level testing. So anytime we can conduct, anytime we will exit from the testing, before giving the bill to the next team, we can conduct the smoke testing. Okay, is it clear, Deepa? Sanity testing and smoke testing. So anyone if asked what is the sanity testing, this is a basic functionality testing we'll conduct whenever we receive the bill from the developer team. And what is the smoke testing means? Smoke testing also is a basic functionality testing conducted by the developer or tester before releasing the bill to the next team or next cycle. So that's the difference. Now, so end-to-end testing, exploratory testing. So end-to-end testing means overall functionalities of the system. Okay, all the functionalities from the beginning to end. So that is basically end-to-end testing. So people will use this term very frequently. End-to-end testing means complete testing all the functionality of that application. That is end-to-end testing. Simple. But exploratory difference is little bit different. So exploratory testing means, suppose if I get some project, okay, you don't have any documents, you don't know prior knowledge of the application. So what you will do, you will explore that application, you will explore it. You don't know any documentation regarding it, you don't have test cases, you don't have documents. Okay, so you don't have the prior knowledge, you don't know about that application. So what you will do then, how to test that application? So you need to explore the functionality, right? By using all the features, you need to explore yourself. So that is basically exploratory testing. Exploratory testing in Windows itself, suppose if you don't know any application after installation, you will see all the files, right? You will see, suppose Windows or MS Word or anything. If you don't know anything, what you will do, you will check all the options what we can do. So by choosing the option, something will happen. So based on that, okay, this functionality is working like this, then you will understand. You're exploring yourself, the functionality you're exploring. This is simply like self-learning. Okay, without depending any documentation, anything. This is like a self-learning, learning of application functionality. So that is a exploratory testing, exploring the application and understanding the functionalities and adding or modifying the existing test cases for better testing, called as exploratory testing. So without having any documentation, without having any knowledge, exploring your functionality. While testing your application, you're exploring your functionality, exploring your application functionality. Okay, to know the functionality. So that is a basically exploratory testing. Explore, the term itself is clearly saying, right? Explore means we don't know anything, we have to explore. Okay, so this is the end-to-end testing and exploratory testing. Next, globalization or internationalization testing and localization testing. And globalization or internationalization testing means some application will support multiple languages. Suppose if you go for online applications, some like PayPal and all, those applications are there. Those applications will support all the languages. That means in the world, all the countries the people will use, right? So it should support multiple languages, or Chinese, or Japanese, or English, or UK, all the countries. So if any application is supporting multiple languages, then we need to test that application. Especially financial and banking applications, they will deal with the currencies, right? So one country to another country, the currency will be differences, the currency conversions and all we need to verify. So that is a globalization testing. So if an application is support multiple languages or multiple countries, then we need to check what are all differences we have. So that is globalization testing or internationalization testing. Next one is a localization testing. So localization testing is basically we need to check whether our application is working according to our local languages or not. Checks the default languages, currency, date, time, format, and etc. So time format is different, currency format is different, language is different. So that we need to verify. Localization testing. Okay. Suppose our application is designed in a particular locality. So for example, application is designed only for in India, then the date format will be different and currency should be different. Suppose the same application is developed for multiple countries, then we need to verify the all the currencies are supporting or not, all the date formats correctly aligned or not. So whatever differences we see, suppose if in India we have PAN number or the other number and so on, but in other countries we have a SSN number and so on. So there are some differences will be there. So that those differences we need to test. So that is the difference between globalization testing and localization testing. Internationalization testing. So globalization testing is also called as a internationalization testing. So in shortcut, we call as I18N. I18N means the first letter is I, the last letter is internationalization, last letter is N, and in the middle we have 18 letters. Okay, so that's the reason we call as a I18N testing. So globalization testing or internationalization testing. Testing your application is supporting multiple languages in the form of dates and currencies and so on. And localization is testing or local currency, local date or local language or not. So that is the difference between globalization testing or localization testing. Okay. Next one. So positive testing and negative testing. So very simple. So if you want to test an application, we need to always think about the positive as well as negative input. So whenever we provide the positive way or positive inputs, the application should also respond positively and it should accept all the inputs. When I provide the negative input, application should throw some exceptions. Okay. So if I provide the positive inputs, application should work successfully. If I provide the negative input, application should reject it. So that is the main positive and negative testing. Sometimes why we need to test the negative testing, because positive testing, when I provide the correct input, it will accept. If I give the negative input, it is will also accept. So that is not expected behavior, right? So we need to always cover the negative test cases. So that's the reason whenever you are creating your test cases, we need to always think about positive as well as negative. So positive test cases provide the testing is fine. So most member of people will think like that. So when I conduct your testing, whatever inputs are enough, so those inputs they will test it, they will work. Okay, they say they think that the testing is completed. No, okay, some inputs will work fine. So if I give some negative inputs, application should not be work. So that is also our expectation. So if when I provide the valid input, application should accept. If I provide the invalid input, application should reject. Simple. So that is the positive testing and negative testing. So all the scenarios, for every scenario, there will be positive test cases and there should be negative test cases. Think that whenever you are writing a test case, we should negative test cases as well positive test cases. This is a common practice we need to do. Next, right? So these are the terminologies. So what are the things we have discussed so far? So ad hoc testing and monkey testing, retesting and regression testing, and sanity testing and smoke testing, end-to-end testing, exploratory testing, localization, positive testing, and negative testing. So these are the few terminologies we use in the real time and day-to-day life. And there are n number of terminologies, hundreds and thousands of terminologies are there, but we don't require all of them. So whatever required basic terminologies I have just explained here. Okay. So is it clear, Deepa? Then I'll move on to the SDLC. Right. So now we are entering into the main topic and real-time process, and this is very useful when you go for an interview. Suppose if you put some experience, then people will ask you the different kind of questions related to the process and environment and tools and everything. So this particular portion of the topics will cover all those things. So please concentrate, focus on everything because these are real-time concepts. So now let us discuss about software testing lifecycle. So STLC is a phase, or STLC is a part of SDLC, software development lifecycle. So especially in STLC, so all the testing team will involved in these phases, right? Right. Test requirement analysis. So testing is STLC start with the requirement analysis and test planning, test designing, test execution, and test closure. So these are the 5 different phases we have. And each and every phase, we have different people involved and different responsibilities we have and different kinds of documents we will prepare. Okay, so altogether every phase having different kinds of activities we have to perform. So not only tester and test managers or test leads or test engineers, all of them will be involved during these phases. So just I'll give you a high level picture. Okay, what are these phases and what are the activities we need to perform, what are the documents we need to prepare, and what are the people, what kind of people involved during these phases. And then we will discuss each and every phase in detail. Okay, so now let me give you just a second. At high level picture we will discuss now. So what is SDLC? What are the roles we need to have, and what are the people involved during the phases, and what are the documents we need to use? What are the input documents? What is the output document? So all these things we need to discuss now. So now I'm going to show you this particular table which explains everything. Okay, so just a second. Let me maximize this. Right. So is it visible? I hope it is visible. Yeah. Right. So now, as I said, testing is having multiple phases, right? So test planning phase, designing phase, execution phase, defect reporting and tracking, and then test closure and sign off. So these are the 5 phases we have in SDLC. So in each and every phase having different inputs we require and different activities we are going to perform and different responsibilities we have, and what there should be some outcome of this particular phase. So once we completed this phase, once we finish this phase, we have a certain outcome. Okay, that means some output we should get after completing all these activities. So let us start with the first one. So test planning. Main focus of test planning is what to test, how to test, and when to test. So this is the main important key areas: what to test and how to test and when to test. So test planning is always focusing on these 3 things: how to test, so what to test means scope of the testing, how to test means what are the types of testings we have to conduct, when to test means timelines, when we have to conduct the sanity testing, when we have to conduct the regression, when we have to conduct the functional. So all the timings related stuff. Okay, so what to test means what are the scenarios, what are the functionalities. How to test means what are the type of testings. When to test means timelines. So test the planning is always focusing on these 3 key areas. And what are the input documents for test planning? So project plan and functional requirements. So these two are the input document. Project plan is already there, which is created by the project managers. So functional requirement is nothing but FRS document, functional requirement specification, or user requirement specification, or system requirement specification, SRS. So all are same documents. Okay, functional requirement document. That's an input for test planning. So once we have these 2 inputs, What are activities we need to perform as part of test planning? Identify the resources. So these are all lead and manager level activities will be more. So test engineer really role is very less during test planning. Okay. So here I'll respond. So I have noted here. Test lead or team lead role is 70% will be there, and test manager role is 30%. But here test engineer role is very less. Strategies test plan is different, Deepa. Sometimes test plan itself contains a strategy. Strategy means what kind of testings we have to conduct. Test strategy means what are the testing types we need to conduct on that application. So that is all about the test strategy. So that is also part of the test plan. Sometimes people will prepare different documents, but most of the times we don't have any specific special document for test strategy. So in the test plan, one of the field is test strategy. Okay. So test strategies talk about more focusing on what are the testings we have to conduct and what are the tools we have to use. So those things we'll talk about by the test strategy. So that is simple. Okay. So test strategy is a part of a test planning. So here I noted 3 points, right? What to test, how to test, when to test. So the how to test will talk about the test strategy. So how to test is nothing but a test strategy. Okay. So here we have two inputs, project plan and function requirement. These are the inputs. And here, if you come to the responsibility, test lead or team lead role is 70% and manager role is 30%. But here the test engineer role will not be there. That means at least 5+ years of experience people will involved during test planning. Okay. So what they will do here, they'll identify the resources. Identify the resources means what are the how many people we have, how many people are know about the technologies, tools, and what are the hardware resources, how many systems we have. Okay. So how much budget we have. So all these things they will choose. They will do some kind of feasibility analysis, that is identify the resources. They will identify human resources and also hardware resources. Human resource in the sense team. Okay. So that's a and then team formation. They will identify all the resources, then they will choose a team. So suppose in the companies there are number of people will waiting for the projects, right? So some people will having the skills and some people are not having the related project skills. So these people what they will do is they will check who is having the project related skills, and then they will choose and they make a team or they form a team. So team formation and test estimation. Test estimation means how much time the testing will take, how much time sanity testing, how many times we need to conduct regression, how much time regression or functional testing should be conducted, when we need to release the build from the next phase. All these things we need to estimate. Time estimation basically. How many people we have, how much time we have, and how much work we have to do on day-to-day basis. So that is called as an estimation. So they do estimation and preparation of test plan. So they will prepare one document with all these things. So in this document, we will have detailed information about what to test, how to test, and when to test. All the timelines. I'll talk about test plan in the next slides in detail. So test plan is also a document which contains main three things: what to test, how to test, and when to test. So this information will be provided in the test plan document. Okay, that they will prepare the test plan document and reviews on the test plan document. Once they have prepared your test plan document, they will conduct reviews, and then they will sign off the test plan document. Once the reviews have been conducted and everything is fine, then they will sign off test plan document. So these are the activities they will perform at the initial phase, that is test planning phase. Okay. So in the test planning phase, we need to focus on three things: what to test, how to test, and when to test. And input documents are project plan and function requirements. And more responsibilities, team lead or test lead or test manager responsibility will be the more. And these are the activities they need to perform: identifying the resources, team formation, test estimation, preparation of test plan, reviews on test plan, and then finally they will sign off the test plan. And what is an outcome? Once the phase is completed, we have a test plan document. So this is an outcome. Okay. So this is a test planning phase, the first phase of STLC. Next one is the test designing phase. So in the test designing phase, what are the input documents? Again, project plan will be there. Function requirement is already there in the previous phase. Along with these two, we need to also refer few more documents, because the test designing phase, the main activity is identifying the test scenarios, writing test cases, reviewing test cases, and so on. So if you want to prepare our test cases and scenarios, we require more detailed level of information. Okay, so that's the reason. Along with the project plan is always talk about the timelines, and functional requirement is the document which will talk about the functionalities, behavior of the application. That is the most important document. And why we need test plan here during test designing phase? Because test plan says this information, what to test. So based upon that information, we need to prepare our test scenarios and test cases. So that's the reason we need to also refer test plan document. So that is also we required. Then design document. And design documents means sometimes there are some design documents also will be prepared. They are the design documents include some picturized format like use case and everything. By seeing the pictures, we will more understand the functionality. Sometimes SRS document contains the paragraphs of text. So by reading the text, we cannot understand 100% full-fledged functionality. Sometimes we need some pictures and diagrams and all these things. So that we need to also refer the design documents, and use cases will be there. So in the real time, the project manager is also having use cases. Use cases talk about the requirement basically. So in detail requirement. By seeing the use cases, we can understand in detail requirement, in detail functionality. So all these things we are going to refer in during test designing phase. Okay, so we are going to discuss all these things in detail again. Okay, what is use case, how the test plan will prepare, what is the function requirement specification, all these things we will discuss going further, very detailed. So here these are the input documents we required during test designing phase. And what are the activities we need to perform? Here, what are the main people are involved here? Test lead and team lead. His role is only 30%, but test engineer role is 70%. Because the main role of writing the test scenarios, test cases, and everything can be done by the test engineers. So their role is 70%. And test lead and team lead, they will review our test cases, our test scenarios, and they will provide the sign off and everything. So their role is 30%. So here, preparation of test scenarios based upon function requirement, docs, use cases, we will refer those documents. We will prepare test scenarios. Then we will prepare the test cases. And once we prepare the test cases, we will conduct reviews. Reviews means again reviews, walkthroughs, inspections we discussed, right? All these things we need to conduct. So first we need to review alone and peer review. We need to provide our test cases to our colleague and the same team, and we need to ask them to review. Everything is fine. Then we need to call leads, managers, dev team, and everybody. And in front of them, again, we need to go through the test case reviews. And if everyone is giving the comments, we need to add those comments. So finally, we need to get sign off from all these team, right? So that is the main intention. So we need to get the sign off. So once your test cases have been signed off, then execution will start. So until unless your test cases have been signed off, we should not start our execution. Okay, so that's as per the company policies and rules. So here these are the activities we have to perform as part of the test designing phase. And here the test lead and team lead role is 30% and test engineer role is 70%. And what is the outcome of this particular phase? We have test cases document and we have traceability matrix. What is traceability matrix? So here we have requirement document. We will prepare our test cases. How we will make sure your test cases have been covered, all the functionalities, how we will know? So we should know about it because we need to separately prepare traceability matrix. So traceability matrix is a mapping of requirement and test case. So for every requirement, there will be some ID number. ID will be there. For the same requirement, how many test cases we have created. So requirement ID and test case ID, we will map together. So that we need to put in the traceability matrix. So by seeing the traceability matrix, we can easily understand every requirement is covered or not. For every requirement we have created test case or not. So that will be very much clear. Okay, if you have traceability matrix. So the outcome of test designing phase is test cases and traceability matrix. Okay, so this is second and most important phase, test designing phase. Is it clear, Deepak? Second phase is test design phase. Now the third phase is test execution phase. As soon as our test cases are ready, traceability matrix, everything is ready, then we will get the build from the developer. And as soon as we get the developer, build from the development team, we need to start our test execution. So what are the inputs we require here? Again, we have function requirement document, test plan. Again, we need to refer because test plan contains the timelines. We need to follow the exactly timelines, and also we need to follow the exact strategy which you have defined in the test plan document. And what are the types of testing we have to conduct? All those things will be part of test plan. So we need to also refer the test plan document and test cases. These test cases are already prepared during test designing phase, right? So we need to see the test cases, and then each and every test case we need to execute and check the result of the application. And the prerequisite is build from development team. So until unless we get the build, we cannot test anything. So we should get the build from the development team. So these are the input for us. If you start test execution, these things should be ready. Okay, that's the entry criteria. You can say these are all entry criteria, prerequisites. And then what are activities we will perform here? Or we'll execute our test cases, and while executing our test cases, we will prepare test reports and test log. So test report and test log is exactly the same. Test log says how many test cases have been executed, how many are passed, how many are failed, how many are blocked. All this information will be there on the test log document. Same thing we call as a test report. At the end of the day, you need to produce the report. And identifying the defects is the main activity during test execution. So while testing or while executing the test case, why you are executing the test case? Because you need to find out the defects in the application. If you find any mismatch between your expected and actual, then you need to identify the defects. You need to report that mismatch as a defect. So identifying the defect is the main activity in the test execution. So test case execution, preparation of test report and test log, and then identifying the defect. So these are the main activities during test execution phase. And now here responsibility, team lead or test lead role is 10% only. Okay, because he will just observe the process and people are working or not, everything is goes well or not. If there are any issues facing, he is responsible, he will solve the issues like environmental issues, development communication conflicts and everything, he'll take care of it. And test engineer role is 90%. So because he has to prepare test plan, he has to prepare test cases, he has to execute your test cases, he has to prepare the test report and identify defects. All these activities is done by the test engineer. So 90% role will be there during test execution. Okay, so what's an outcome of this particular phase? We have a status or test reports. Okay, final test reports is the outcome. So test execution and defect reporting and tracking both are parallel phases actually. So it is not one phase after another phase. Test execution and defect reporting and tracking. So these two phases are parallel phases because whenever we execute our test cases, immediately we will find the defect and we will report the defect. And then we go for another test execution. So 3 and 4, these two phases are parallel phases, not one after the another. Okay, so while test execution itself, if you find any defect, we will report it and we will track that defect. So that's the main intention here. So here are the inputs for test cases, test report or test log. Because if you want to report the defect, we need to have the clear information. What is the defect, where it is failed, why it is failed, okay, what are the inputs we require, what is the test data we required, all these things we need to require. So we need to have test cases and also test reports and test log. And the main activity here is preparation of defect report. So we need to prepare our defects, but nowadays we are not following any documentation like Excel sheet and MS Word documentation. So we have a tools, automation tools. So through automation tools, we can directly report the defects. So preparation of defect reports and reporting defects to developers. So these are the two main activities during defect reporting and tracking, right? So here, and test lead and team lead role is only 10%. Test engineer role is 90%. And finally, we will get outcome as a defect report. Okay, so this is the fourth phase of SDLC. And the last one is a test closure or sign off our testing. So when we need to stop our testing. So here, there are some criteria there. So if you match that criteria, if you go to that particular criteria, then we can stop our testing. Okay, so we'll discuss in detail what is the criteria and everything next slides. So here, if we want to stop our testing or if you want to sign off our testing, we need to have test reports and defect reports. Okay, so test reports and defect reports is the input criteria. So based on this, we will conduct a review. Review means how many test cases we have executed, everything is passed or not, is there any defects still there or not, so timelines are being completed or not. So all these things we will review. So once all test case designing, execution, reporting, everything is completed, at the end we will conduct a review meeting within the team. So then they will discuss all these criteria. So everything is fine, then they will sign off our testing. So if you want to conduct that kind of review, test reports and defect reports, all these things are required. Okay. So based upon this, they will take the decision. Now analyzing the reports, analyzing the bug reporting, and then evaluating exit criteria. These are all activities during test closure or sign off phase. And again here, test lead or test manager role is 70% because they have to tell based upon reports which we have prepared. They have to tell, do we need to stop testing or still do we need to wait for some other build. Okay, so test lead, test manager role is 70% because they are the decision makers, and test engineers is only 30% because we will help them to analyzing the report, bug reporting, and everything. Okay, so finally we have a test summary report. This is an outcome of the phase. Test summary report means it contains all the document, whatever document we have prepared above, everything will be there in the test summary report. Okay, so this is a high level STLC process and activities. What are the different phases? What are the inputs required? What are activities we are going to perform as part of the phase? What are the responsibility and what kind of people they are involved? And what's an outcome of that particular phase? Okay, so is it clear, Deepa? Any questions on this? So this is a STLC process. So now we will go each and every phase. Okay, test planning phase, test design, execution. Just we have discussed about at high level overview of the all the things. So now let us go and see each and every phase of STLC in detail. Now again I'm come back to STLC PPT. So first requirement analysis, test planning, test designing, test execution and defect reporting and test closure. These are the main STLC phases we discussed, right? So now let us go at first one. So this is STLC life cycle analysis, test planning, test case development, environment setup, test execution, test cycle closure, and everything. Right. Yeah. So this exercise just now I have explained. Right. So now let us move on one by one. So after completion of this STLC, so each phase we need to again dig into it. So test plan. So what is test plan basically? So test plan is a document. People will ask in interview point of view, these are very important questions. Okay, people will ask you what is test plan, what it contains, and who will prepare test plan. So these are important questions. So test plan is a basically is a document, okay, which will prepared by a senior people like leads or sometimes managers. And what it contains, it is main focusing on three things like what to test, when to test, and how to test. And it contains the scope of testing, approach, what are the resources, and schedule of the testing activities, all these things. That is simply basically test plan document. So if anyone asks you, we can simply explain. So what is test plan? Test plan is a document which will focusing on what to test, which will talk about what to test, how to test, and when to test. So that's a test plan. Who will prepare test plan? Or senior people like test leads and manager will prepare the test plan. What it contains the scope of testing, like what to test, what not to test, what is the strategy, what are the tools we have to use, what are the timelines, what is the criteria, all these things will be there in the test plan document. So these things we need to explain. Now we will see detailed information. What is the test plan contains? What the test plan contains? So the main objective of test plan, features to be tested, features not to be tested. So test approach, exit criteria. So here the test approach is there, right? So that is a basically strategy. This is also called as a strategy. Okay. Entry criteria, exit criteria, suspension and resumption criteria, test environment, test deliverables and maintenance, milestones, test deliverables and milestones. So schedules, risks and mitigations, approvals, all this information will be there in the test plan document. Okay, it is a high level document. Leads and managers they will prepare this document. Thus this is simply as a test plan document. Nowadays in the agile process we don't have all these things. Documentation is very less in agile. So nowadays we don't have any requirement document, we don't have any test plan document. I'll come to that whenever we execute we will explain the agile process. Okay, but as a tester we need to understand all these things. So test plan is a document which will talk about how to test, when to test, and what to test. So if you go for the contents of the test plan document, so these are the contents. Okay, so these are the test plan contents. So now let us understand the use case, test scenario, and test case. So we have just now we have discussed about the use case. So use case is nothing but it describes a requirement. It is a part of requirement. Use case. I will show you some sample use cases. Okay, how it will be. So use cases are part of requirement document. So what is the requirement document we have? SRS document or FRS document. It contains the use cases. So use case is describes the requirement. Like sometimes the documents can be different. So sometimes the document is having only text, and some documents having only pictures, and some documents having only data flow diagrams and interrelationship diagrams like flow diagrams. So and different format are there, so each and every company that will be vary. But use case is nothing but it is small kind of a picture which will give you the clear flow of the functionality. So that is simply called as a use case. So use case is a part of requirement which will describe the requirement basically, which will describe the functionality more. It contains three things. First, actor, action and the flow, and what's an outcome. It will be like this. Simply I'll simply draw a small use case, then you can understand. Use case describes a requirement. Remember, use case will always talk about the requirement. It contains three things: actor, action or flow, and outcome. So how it will be? Simple. For the login process, I will give you small use case like this. The picture will be like this. He is a actor. He is a actor or user. And here this is a login screen. This is a login screen. So this is an action. So this is an action. Now here what's an outcome? So after logging, what is an outcome? This is a home page. So this is a home page. So this is outcome. So this is a simple use case for the login process. Similarly, I will also going to show you a few more use cases. Then you can understand. Okay. So these are the use cases or test scenarios or test scenarios. Use case is nothing but it's a part of requirement. It is a part of requirement. It contains three parts. One is actor, action, and outcome. Okay, that's the use case. Now, what is a test scenario? So, test scenario is a possible area to be tested. Possible area to be tested. So, that is basically what to test. So, test scenario describes what to test, high level scenario. And test scenario contains, see, one use case contains multiple test scenarios, and one test scenario can contain multiple test cases. Okay, use case is a part of requirement. Test scenario is a possible area to be tested. What's the main area to be tested? What to test? So that is the test scenario. Test case is nothing but how to test. This is most important. Test scenario means what to test. Test case means how to test. How to test means we have some steps. So enter username, enter login, click on OK button, and check whether the home page is displayed or not. So this is how to test. And what is test scenario for this? Check login process. So that is the scenario. That is a scenario. And for this scenario, how to check the login process? We need to write detailed steps. So that is test case. Okay. So test case is focusing on how to test. Test scenario will focus on what to test. And test case describes test steps, expected result, and actual results. So test case is expected result and actual result. If both are mismatched, then we will find as we will report as a defect. Okay. So this is very important in interview perspective also. What is the difference between use case, test scenario, and test case? So use case describes the requirement. It contains three parts: actor, action, and outcome. Test scenario is a possible area to be tested. The main focus is what to test. And test case is the main focus of test case is how to test. Means in detail steps we have to write. So that is all about the test case. So people will ask, what is the difference between use case and test case? These two. What people will confuse, most of the people will confuse here. Use case and test case. The people will think exactly the same. It is not the same. Use case is a requirement. It describes the requirement which is part of the requirement document. And test case describes the how to test the requirement, how to test that use case. So that is the main focusing of the test case. Okay, so one use case can contain multiple test scenarios. Similarly, one test scenario can contain multiple test cases. That is up to the use case complexity. Okay, so is it clear, Deepa? Use case, test scenario, and test case. So these are the three important things which we need to understand. So use case is a part of requirement. It describes the requirement. It contains actor, action, and outcome. Test scenario is a possible area at high level. What are the different areas we need to test? What to test? And test case is the more detailed steps. How to test. So that is the main of test case. Now here I have just mentioned the same point, use case and test case. So use case describes the functional requirement prepared by the business analyst. And test case describes the test steps and procedure prepared by the testing. So that's the difference between use case and test case. Now, test case versus test scenario. So test cases will be derived based upon the test scenario. So test scenario is high level. What to test? So here test scenario will describe what to test, the area, possible area. And test case describes how to test. So test case is depending on test scenario. If you have a test scenario, we can create any number of test cases. Now if you see here this example, so the test scenario is checking the functionality of the login. This is a test scenario. For this scenario, we have created multiple test cases. The first test case is click the button without entering username and the password. This is the one test case. Click the button only entering the username. This is another test case. Click the button while entering the wrong username and wrong password. This is another test case. So one test scenario can contain multiple test cases. Okay, scenarios talk about what to test and test case will talk about how to test. So that's the difference. Okay, so here I have mentioned this point. Next, so positive versus negative test case. So we have discussed about positive testing and negative testing. So what's the positive testing? If I provide valid inputs while testing, that is a positive testing. When I provide invalid inputs, then application should throw an exception or some warnings. So that is a negative test. So positive input should accept, negative input should reject. So that is positive and negative testing. Now here positive test cases and negative test cases, both are required. Okay, so here I have mentioned few examples of positive test cases and negative test cases. So now I have one requirement here. I have a text box. So this is my text box. Okay, my requirement is the text box is listed as a feature as an SRS and mentioned as text box accepted 6 to 20 characters. This is the range. 6 to 20 characters are the range. Only alphabets. Only alphabets. Alphabets means you should not allow special characters and you should not also allow the numbers. The range is starting letter should be 6, minimum range is 6, the maximum is 10. So that's my requirement. So how to write the positive test cases for this? So these are the positive test cases. Text box accepts 6 characters. This is positive because the minimum range is 6. And text box accepts up to 20 characters length. So that is also correct. As per the requirement, it will allow the 20 characters. That is also positive test case. Text box accepts any value between 6 to 10, 6 to 20. So that is also positive. Text box accepts all alphabets. So that is also positive test case because as per the requirement, it should allow only alphabets. So these are all positive test cases. These are all positive test cases. Now come to the negative test cases. So negative test cases. See now, text box should not accept less than 6 characters. So if I give 1 to 5, it should not accept. If it is accept, that is a bug or defect. So that is a negative test case. And text box should not accept characters more than 20 characters. So because maximum length is only 20, if I provide more than 20 or 21 or 22, it should not accept. And text box should not accept special characters Text box should not accept numerical numbers because it accepts only alphabet as per the requirement. So this way we can always think about positive test cases and also negative test cases. Okay, for every test case we have positive as well as negative. Now, test case design techniques. We are slowly entering into the test designing phase. Okay, test design technique. So, in the test designing phase, if you want to prepare your test cases, we need to use certain techniques. We need to follow certain techniques. They are very important in even interview perspective. People will ask you what is boundary value analysis, what is ECP, what is the decision table, what is state transition diagram, what is use case testing. All these things are very important. So these are all called test design techniques. Okay, if you want to design or if you want to prepare your test cases, we should follow these techniques. While preparing your test cases, we have to follow these techniques. Okay, so in the previous sessions we already talked about boundary value analysis and equivalence partition, right? So what is boundary value analysis and equivalence partition? Very simple. We will prepare equivalence. Boundary value analysis is nothing but the range of values, and ECP is nothing but the valid or invalid data. Valid or invalid data. We will prepare some table, right? If it is a BVA, we prepare here minimum, maximum. There are 6 parameters, and minimum minus 1, minimum plus 1, and maximum, maximum plus 1, maximum minus 1. So if you test these 6 scenarios, that is more than enough, right? That is the one technique to reduce the number of inputs. Suppose if you go for previous scenario here, 6 to 20 characters are allowing, that's the range, right? But we no need to test for 1 to 5, and again 6 to 19, again 21 to we don't know, right? All the numbers, we don't need to test all these things. We will take only 6 parameters. What is that? Range. So 6 is a minimum, 20 is a maximum. So this is minimum we will check, this is maximum we will check, and before the minimum just one value is checked like this. If it is 5 is failed, then we no need to check 4, 3, 2 and 1. Similarly here, maximum is allowed. If we check 21, if it is failed, we no need to check again 22, 23 and so on. Okay, and after 6 and 20 we no need to check all the numbers. So after 6 if I check only 7, that is fine. So if it works all the numbers. If I check before 20, that is 19, that is fine, it will check all the numbers. This is called as a boundary value analysis testing technique. Basically this technique is used for to reducing the number of inputs. Okay, similarly for the ECP, equivalence class partitioning. So equivalence class partitioning is as per this requirement, this is allow only alphabets. So what we need to do, we will prepare some table. This is equivalence class partition table. Here we will mention what is valid data, what is invalid data. So here a valid data means only alphabets. Invalid data means special symbol should not be having and numeric should not be having. So based upon this techniques, we will prepare our test data and test cases. So that is a boundary value analysis and equivalence class partitioning techniques. And the decision table. So see this, for the same login screen, I have prepared some decision table. So this is also a kind of technique. So in decision table, there are two things. One is actions and the other one is conditions. So these two are the important terms. Decision table contains two columns. One is actions and conditions. So first, in which condition? In this condition, what is an action? Actions means, suppose if I provide email ID valid, password is valid, then my expected should be passed. Okay. And when you provide email ID is valid, password is invalid, then my expected is failed. So like that, we will specify all kinds of possible inputs in the decision table. Okay. So this is also, this is called as a decision table. Conditions and actions. Conditions and action. So if valid, if email is valid and password is valid, that's the condition. Then what is an action? Action to be performed. This action is response by the application action, not our action. Okay, this is application action. Suppose application is taking both are valid. Application, what is an application action? Application should pass. Similarly, if the condition email and password is valid and invalid, in this condition, this is an action, fail. And if I have invalid and valid condition, again the application action is fail. Similarly, we can create number of inputs by using decision table. This is also one kind of technique for creating your test cases and test data. And state transition diagram. So this is also a kind of testing technique. So here I have given a small scenario for testing your ATM machine. Okay. So here state transition diagram means every time whenever we do some action, the state will be changed. Okay. So in some scenario, this transition diagram is very useful, very useful. Some particular scenarios, if you want to write test cases and all. See this, it will just talk about the flow of ATM. Very simple. We will insert the card. We will insert the card in the ATM at the first step, right? After that, what happens? It will wait for the pin and then we will enter the pin. So see now, whenever we perform the action, the state is changed. Here round circles will represent the sound, represents the states. So sound, circles will represent the states. This is one state and this is another state. Okay, every state is transitioning one state to another state based upon our actions. See now here, when I insert the card, what happened? Start state to wait for the pin state. It is changed. And whenever I enter the pin number, again it is changed to another state. If pin is okay, then it will go to the access to account state. If pin is not okay, it will go to another state. So here it will ask pin not okay. If pin is not okay, then it will go to another state here. And if your pin is okay, then access. So if first time when I enter the pin, if it is wrong, it will ask you once again, right? How many times it will ask? 3 times it will ask. If I enter wrong pin number, it will ask 3 times, right? So that's the reason here I mentioned 3 tries. 3 tries. So first try, if pin is okay, then it will go to account. You can able to access account. If first time pin is not okay, then again it will ask second time. If second time if you enter the pin okay, then it will go to the account. If second time is also pin not okay, then again it will give you third time. If third time pin is not okay, card will be gone or card blocked. So something will happen. If third time pin is okay, then account can be accessed. So this is basically state transition diagram. So based upon our action, the state can be changed. Okay. So this is another technique. So before writing the test case, we need to draw all these diagrams and make sure everything is covered or not. Okay. So this is another technique of state transition diagram. Next one, use case. Now, so far just now we have discussed about the use case, right? What is the use case? Use case is a part of requirement document. It contains the actor, action, and outcome. 3 parts. So use case is a part of requirement. If I use case can be used for testing technique. If you want to write a test case, use case is required. So this is a simple use case. If you have observed here, uh, there are two components here, actor and the system. So here these two people are interacting, actor and the system. So the same scenario, this is a state transition diagram, right? For the same scenario, this is a use case. So first we insert the card, that is action. A means actor, okay? Actor will insert the card. Inserting the card is an action. Actor can perform the action. So A is an actor, inserting card is an action. Now second step, what system will do? This is the outcome. So validates card and ask for the pin. So what actor will do now? Enters the pin. So actor will perform the action. Entering the pin is an action. Now what system will do? It validates the pin. And then what system will do? Allows access to account. So this is the first scenario. These are the steps actually. These are the steps 5. Extensions. Now here see, observe. In the second condition and fourth condition, there are, suppose the pin is not valid. So then what are the another actions we need to perform? Suppose 2A, and the second step we just need to system validates the card and ask for the pin, right? Suppose card is not valid, then what happens? It should display message and reject the card. And fourth step, validate the pin number. Suppose pin is not valid here, then display message and ask for the re-entry twice. And 4B, pin is invalid for 3 times, then eat card and exit. So this is simple use case. So based upon the use case, we can prepare this test transition diagram, and also we can write our test case. So these are all inputs for us to understand the functionality more, a little bit better. Okay. So these are all called test case techniques. So what are the testing techniques we have? In interview, people will ask, what are the testing techniques we have? Boundary value analysis, equivalence class partitioning, decision table, state transition diagram, use case testing. Based upon the use case, we can prepare our test case. That is use case testing technique. So these are the 5 techniques we have for test designing. Okay, so in interview you will get lot many questions on this. They will give some scenario, they will ask you to write boundary value analysis equivalence partition on, or they will ask you to write decision table, or they will ask you to write state transition diagram like that, and they will ask you to just give one use case, sample use case. So you need to prepare all of them. Next one. So now so far we discussed about the testing techniques. Now test suite. So what is test suite? So test suite is a group of test cases which belong to the same category. So as I said, we have a test plan document, right? In the test plan document, we will create more number of test cases. So sanity test cases is one category. Let us say these are all sanity test cases, and these are all regression test cases. These are all functional test cases. So every same category of test cases comes under one test suite. Either we can call sanity test suite, we can call regression test suite, we can call functional test suite. Test suite is nothing but a group of test cases which are comes under the same category. So that is a test suite. Simple. Okay. So people will ask you, just whenever we get the bill, what kind of test suite you need to execute? Sanity test suite. So whenever we get the new bill after fixing the issues, then what is the test suite we need to execute? Regression test suite we need to execute. And once the sanity testing and regression testing is completed, then what test suite we need to execute? Functional test suite we need to execute. So based upon the test state and criteria, so we need to choose appropriate test suite. Yes, clear? Deepa, any questions so far? Are you following? Yes. So now we have just talked about what is test case, right? What are the techniques we need to follow to design the test case, and what's the test suite and all. Now, test case contents. If you want to prepare a test case, what are the details should be there? So usually we will prepare our test case in Excel sheets first at the beginning. So till all the reviews have been completed, everyone is signed off, then we will upload those test cases in your test management tool. So first initial level, we will start preparing your test cases in test case document itself, right? So test case ID, test case title, description, precondition, priority of the test case, requirement ID, what are the steps and actions to be performed, expected result, actual result, and test data. All these things will be part of our test case. All these things will be part of our test case. Okay, so every test case having a unique ID, that is test case ID. And title we should specify with one line. Title should not be bigger. So when I see the title, I should able to know what kind of functionality I am going to test. So title should be very simpler and smaller. By reading the title, we should able to understand the functionality. And description can be 2 lines or 3 lines, that is fine. And precondition means if you want to execute my test case, what are the precondition is required? Okay, what kind of environment is required? What kind of test data is required? So that is all about the precondition. And every test case is having priority. Priority means when priority defines when we need to execute the test case. If it is a sanity test case, at the beginning stage we will execute, right? We need to check whether the build is stable or not. So all sanity test cases comes under the P0. P0 means high priority, high priority. First stage we have to execute. P1 means regression test cases. P2 and P3 means functional test cases. In functional test cases also very low priority test cases also little bit there, or spelling mistakes and UI colors related stuff. So they are low priority test cases, P3s. Okay. Requirement ID also should be there because we need to map the requirement ID, and this test case is written for what requirement. So that will be known by specifying requirement ID in the test case document. And then test steps and actions. So what are the steps we should be performed on the application, or actions, step by step, 1 2 3 4, like that. Every step we have to specify, and for every step what is the expected result, what is the response from the application. So that also we need to specify, and actual result will be noted at the time of preparing your test cases. Actual result column will be empty, and at the time of execution we need to get the actual result from application, and then we need to specify that actual result in the uh, document, test case document. If you find any mismatch between expected and actual, then we need to report as a defect. And then test data also part of the test case. Some test cases require test data, so test data also part of the test case, right? So these are the contents in the test case. So this is a test case template. Simply in the Excel sheet we will write the test cases, right? So these are the sample template of the Excel sheet. So module name, requirement ID, test type, priority, test case ID, test scenario, precondition, test cases and steps, actual result, expected result, result. So all these things will be part of the test case. Okay, this is a sample document or test case template. So this is simply requirement traceability matrix. So as I said, requirement traceability matrix, why we need to prepare? To make sure all the requirements have been covered or not. What test case is covered? We have created test cases for all the requirements or not. So if I prepare parallelly a test traceability matrix, then it will say, by seeing this traceability matrix, we will know all requirements have been covered or not. So mapping of requirements and test cases, that is requirement traceability matrix. Right, so now we have discussed about what is test case, what are the test case contains, and what are the documents we need to refer while creating your test cases, and what are the types of test cases. Now characteristics of good test case. If you want to write a good test case, effective test case, and what we need to follow, what are the main characteristics we should to consider. When you write your test case, it should be accurate and test what it is intended to test. Your test case should be exactly accurate, and it should able to find the defect. That is the main important thing. Why we are creating the test case? To find out the defect. So our test case should able to find the defect. That's the main intention of writing your test case. And no unnecessary steps should be included in it. Sometimes some people write 15 lines of test case or 20 lines of test case. We should not have those many lines of test case. Test case should be very simple, should be very clear, and everyone should be able to understand. If the test case is having more number of steps, it is complex, then we have to divide the test case into 2 or 3 test cases. Okay, multiple test cases. But most of the time we should not, our steps max 10 steps. So we should not exceed our test cases. We should test case should not exceed 10 steps. So max 10 steps. If you have 10 steps, that will be considered as a complex test case. If it is more than or exceeds the 10 steps, we need to split that test case into 2 or 3 pieces. Okay. So unnecessary steps we should not include in the test case, and it should be reusable. Reusable, the same test case can be executed by other persons, can be executed by the future. So it should be reusable, and it should be traceable to requirements. That means as I said in the traceability matrix, right? So by seeing the test case, you should able to tell what requirement we have created this test case. For what requirement we have created this test case. So by seeing the test case itself, we should able to know for what requirement we have created this test case. And it should be compliant to regulation. It should be compliant to regulation means as per the company follows and rules and regulations, we have to follow certain templates. We should not use our own templates, or we should not use any online templates and all in the real-time environment. Whatever template they have followed, whatever the process they have followed, the same thing we have to also obey them, and we need to follow. Okay, that's a compliant to regulations. And it should be independent. You should be able to execute it in any order without any dependency on other test cases. Every test case should be independent. Okay, suppose there is some scenario like you have to log in into that application, then you have to perform a money transfer in the banking application, right? So you should not write one test case for entire functionality. So login is one test case, Okay, so see this, there are two scenarios. One is I have to log into that application. After login I have to verify the balance inquiry. Let us see. So this is my functionality. So some people, the person one written the test cases like this. He has created test case 1, login, and he also created one more test case called as a balance inquiry. Okay, so he has created two test cases. The first test case is having only login steps, and second test case is having login steps as well as balance inquiry steps. So now, is there any dependency between these two test cases? If I want to test this, I don't need to execute the login test case because these steps are already included in the second test case. This is independent. So we have to create test cases like that. So if you give one test case to some other person, he will start from the beginning, right? Suppose if you miss the login test cases, you say this test case is depending on this one. This test case doesn't know the people because this test case, the second test case, you have provided to the people. So they will confuse. So the test cases should not have any dependency. Remember this, okay? And it should be independent. And it should be simpler and very clear. Any tester should be able to understand it by reading the words. Okay. So that is the main important part. If you provide your test cases to some other person, he should be able to clearly understand those test cases. In that way, you have to create your test cases. And then those test cases will be good test cases if you follow these rules and regulations. Now, if you want to prepare test data is also required for the test case. So test data will be provided as an input to the test cases, and usually we'll prepare the test unit, we'll maintain the Excel sheets. So if you have complex data, especially if you have calculations and all, we need to prepare this test data and keep this test data in the Excel sheets. Okay. Now test environment. So if you want to execute now we have just completed our test designing phase. Test planning phase we have done, test designing phase. So what is test case we have understood, what are the test case contains, how to write the test cases, what to be the good test case, all these things we discuss. And testing techniques we have to follow all these things. Now test environment are called as a test bed. Test environment is also called as a test bed. So before executing our test cases, we have to set up our environment. That's called as a QA environment. So test environment decides the software and hardware conditions under which work product is tested. Suppose the product is developed and they are providing us, so we need to have certain environment. What kind of environment? Hardware and software. So if you want to test a product in Windows operating system, our system should be having Windows operating system. Or if you want a product is tested in the Linux or Unix platforms, we need to set up Unix and Linux platforms. And multiple browsers, multiple operating systems. All these things should be there. So that is the test environment setup. Okay, sometimes, especially for product-based companies, the product should be tested on multiple platforms. So in that case, we need to request for those environments and we need to make sure everything is ready before we start our execution, before we get the build from the developer. So that is test environment setup. Okay, so this is the another step before going to execution. Before jumping into the execution, we have to make sure our environment is perfectly ready or not according to the application. Now we are entering into the test execution phase. We have completed test planning, test designing. Now we are entering into the test execution. So during test execution phase, what we will do? By this time, we will get the build from the developer. We will start executing our test cases, whatever we have. Right? So test plan, test cases, everything is signed off, everything is ready. Now the thing is we need to start our execution. So during test execution, we will execute all our test cases based upon the priority. So we need to follow priority. We should not execute test cases as your wish. Okay. So while creating your test cases, we have to give the priority P0, P1, P2, P3, right? First, we need to execute P0, and then if the functionality build is stable, then we need to execute P1s, and then we need to execute P2s, and then P3s. So this is the order we need to follow. And at the time of test execution, we need to find the defects. So Any mismatched functionality found in application is called as a defect, bug, or issue. We can call it with any name. So if any mismatched functionality at the time of execution, we will consider as a defect, and then we'll report that mismatch as a defect to the developer. Okay. And previous days we use some templates, Excel sheet templates, but nowadays we don't use any templates. We are using defect reporting tools. Okay, the ClearQuest, DevTrack, Jira, Quality Center, or Bugzilla. These are all examples of the defect reporting tools. Just they will give you a form, so we need to fill all the defect related information. Just submit. Automatically, that defect will go to the appropriate developer. Okay, so defect reporting. And in the defect report, what are the information we need to provide to the developer? So if we find any defects, we should not say directly, okay, there and so is not working. That is not official communication. Okay, we have to communicate defect in proper way to the developer. So all required information we need to provide to the developer. So defect ID, description, version, okay, in which version of the build we found a defect, and what are the steps we need to perform to reproduce the defect, and when we have raised a defect, what is the reference document, where detected by. So what is the test engineer name, what is the status of the defect, who is fixed by, and date close, severity and priority. All these things are very important. And when you come to the test case, we have only priority. When you come to the defect report or defect is having severity as well as priority, both the things. Test case is having only priority, but there the priority says when we need to execute the test case. But here the defect says priority and severity. Severity says the seriousness of the defect, the impact of the functionality. Priority says how much earlier the defect should be fixed. How much earlier the defect should be fixed. So that is a talk about priority. So priority of the defect is different, priority of the test case is different. Okay, I'll talk about more on this. So these are the different contents we should have in the defect report, which we need to which we need to send to the developer. Okay. Now, so defect management process. So whenever we find the defects, the discovery happens. So discovery means finding out the defect. Immediately what we need to do, we need to categorize is the defect. What kind of defect it is? It is a standardized defect or functional defect or UI defect, or it is a showstopper. What kind of defect it is? What kind of impact it has? So that we need to first categorize the defect. Okay. And the second thing is we need to resolve it. Immediately whenever we find the defects, immediately we should not report the defect to the developer. Once we categorize what kind of defect it is, at least 3 times we have to perform the steps. At least minimum 3 times. Every time if we are coming, the defect is coming, then we need to report. Okay. So first, as soon as we get the defect, we have to think about the resolution. Resolution means what we need to do next. So before reporting before reporting the defect to the developer, once, twice, and thrice, we need to cross check. Maybe sometimes the environment error, sometimes there may be some software error or internal environment error may be there. Okay, this is actual issue with the functionality. There may be some issue with the environment. We need to think all this. Sometimes the issue with the browser, sometimes with issue with the hardware, sometimes issue we have done some mistake, sometimes it is not expected as per the requirement. There are different cases are there. So once, twice, and thrice we need to think about all this internally, and then we need to think about the resolution, and then we need to re-verify, and then we need to close the defects. So, and reporting happen if the defect is not closed or defect is still not fixed, then again we need to report the defect to the discovery. Okay, we need to categorize, resolution, verify, and close. After verification defect, we have to close. Okay, here this is the first step actually. Okay, we need to report the defect, discovery, categorization, resolution, verification, and defect closure. This is a defects management process at high level. Okay, and now, as I said, test case is having only priority. So test case priority says when we have to execute the test case. But here the defect is having two things, severity as well as priority. Severity says seriousness of the defect, how impact it is. And priority says how much early the defect should be fixed. Suppose if it is a critical defect, that priority should be P0. It should be immediately fixed. Suppose if it is a high severity defect, maybe that defect should be closed as early as possible, or maybe the fixed in the future. So severity always designed or defined by the tester. Remember this interview, you will get lot many questions on this. What is severity? What is priority? Who will decide severity? Who will give the priority? Okay. So all these things you will get. So severity is nothing but seriousness of the defect. Seriousness of the defect. How much it is impacted. And which is defined by the tester. Which is defined by the tester. Now, priority is how much early it is fixed. It should fixed in the next build, or it should fixed in the next release, or it should no need to be fixed. Who will decide? Developer and also business analyst. Okay, who are writing the product, who is the responsible for the project, they will decide the priority. We also give some priority, but they may change the priority. Suppose I said it is a high defect, high severity defect, I am also giving the priority as a P1. Then developer may not thought it is an urgent. So he will say, okay, after 2 days I will fix, or I will fix it in the next release. The same issue, our priority can be different and their priority can be different. But who will give the ultimately what's the high priority or not? The business analyst will give. At the client perspective, which is high priority or not. Okay, simple example I tell you. So here I don't have the logo on the application. Every application there will be logo present, right? Logo is not present. So is it what kind of severity it is? Is it critical, high, medium, or low? Suppose I have 30 days of time. I have 30 days of time. I'm in the first day of testing. I have total 30 days of time. I have to complete entire testing within the 30 days, and 30th day I have to give my application to the customer. I am the first day. First day itself, I got an issue called logo is not present. This is my issue. Now, what is the severity? What is the priority? So, logo is not present. Even though if you don't have the logo, we can continue other testings, right? That is not much important for us. So here I will give severity is a low or medium. Low or medium. It is not high and also it is not critical because I'm able to test other things. Logo is just an image, nothing else. Fine. At the first day, this is the condition. Now, slowly we have reached 30th day or 25th day now. Currently we are in the 25th day. Now, still the logo is not present. Now, what's the condition here? What's the condition here? Logo is not there. Now, first day, medium is the low is the severity and priority is a P3. Priority is a P3 now. In the first day, the logo is not present. So logo will not stop our testing. So we have given just medium or low severity at the first day. But when we slowly reaching 25th day, here and the next another 2 or 3 days we have to deliver the bill to the customer. So here everything will be changed. Here the priority will be high. Priority will be high because in the next 1 or 2 days we have to release the customer. So priority to be high and severity will be the still low, but still the priority will be high. This is the one case. Okay. Suppose I get the bill. After installation, the login itself is not working. Login screen itself is not working. Then what is the severity and what is the priority? That is the critical. Until unless login is not working, we cannot proceed the other test cases. It is completely blocked. So the critical test case, critical bug. And what is the priority? P1. P1. Okay. So based upon the situation, based upon your condition, we need to decide severity and priority. Now I'll give you more number of examples, then you will understand. Okay. So these are the severity types: critical, high, medium, and low, and priority P1, P2, and P3. So when we have to give critical, high, medium and low. Suppose while testing installation is failed, or even though installation is successful, some pages are not displayed. So will you be able to continue testing? No, completely blocked. So that time we have to give as a critical. Critical means showstoppers. The other name for this is showstoppers. Showstoppers in the sense we are completely blocked our testing. We are not able to continue the further. So that is a that in that case we have to give the critical. And the second thing is high. The bug is high, but still we are able to continue the testing. Right? So that is high priority. And medium and low is very medium is let us say functionality is working fine, and like a UI defects like alignment and color spelling mistakes, all these things comes under the medium or low severity. Okay, so based upon the time we have to give the priority. Suppose tomorrow I have to deliver the bill to the customer, then high priority. And based upon the timelines we have to give the priority P1, P2 or P3. So we will discuss more number of cases. So defect severity have explained here. Defect severity is a critical, high and medium and low. So this defects indicates complete shutdown of the process. That means you are not able to proceed further. So in that case we have to give critical, and high we have to give. When we have to give high, it is highly severe defect and collapse the system. However, system parts of the system remains the function. Other functionalities we are able to proceed. So that is the case high. And medium, it causes some undesirable behavior, but the system is still functional. Some behavior is not expected, but still we are able to go further. That's the medium. Low means it will not cause any major breakdown of the system. So that case we are going to give the low severity. Similarly, priority. So priority high, medium and the low. So suppose based upon the timelines. For example, here the defect must be resolved as soon as possible as it affects the system severely. It cannot be used until it is fixed. So that is in that time we have to give as a high priority. So P2 is a medium. So during normal course of the development activities, defect should be resolved. It can be wait until a new version of created. Sometimes defect is there in the first build. We should able to continue testing till the next build comes. So in that case, we can provide the P2 as a medium, and P2 is a completely low. So maybe in the next release or the next timelines, they will decide. So priority is not in our hand. Just whatever we feel, we will give some priority. Again, the developer can change the priority, or business analyst also can change the priority. But severity must be given by the tester, and severity should not change by any other person. Okay, developer or business analyst should not change the severity, but the priorities they can change. Okay. So sometimes these are the categories. So sometimes we have priority lower urgent or severity critical and non-critical. This is a graph. So if I find any defect, that defect can be comes under any one of the area, or this area or this area, this area or this area. Sometimes our defect can be urgent defect and urgent or urgent priority, but very critical situation. Sometimes our defect can be landed here. Sometimes our defect will be landed here. It is very urgent, but not much, not critical. Sometimes, and sometimes our defect is very low. Priority is very low, but it is more critical. And sometimes our defect is very low, but it is also not critical. Okay, so our defect will be landed of any one of these area sometimes. Okay, now sometimes our defect can be low severity and high priority, or high severity and low priority. In interview, people will ask, can you tell me one defect which comes under the low severity and high priority, and one more defect which comes under the high severity and the low priority? Can you give some example? So you will get questions like this. Okay, so I will give you few examples. You can answer them easily. So here I have given two examples. I have given more examples. You can remember one example, that is more than enough in interview perspective. Okay, so the first one, low severity, high priority. So people will ask you, can you give me one example, one defect example which is low severity and high priority? So see this scenario here. A logo error for any shipment website. There is a website called shipment website. A logo error is there. Can be of low severity. So logo is not critical, right? So it is low severity as it is not going to affect the functionality of the website. So logo will not affect any functionality, right? So it is low severe, but can be of high priority as you don't want to any further shipment to proceed with the wrong logo. That means logo is an error. Instead of this logo, there is some other logo is present. So logo is wrong. That's basically in the website, the logo is wrong. This will not impact the other functionality. So it is severe. It is not severe. It is low severity. But logo is wrong. Means instead of putting the logo, if we don't have any logo, doesn't matter. But logo is there, but it is wrong logo. It is not our expected. So and then it is immediately changing. So that is high priority as per the customer point of view. Customer will always think about the logo, right? If the logo is wrong, customer will not be happy. The company logo is mandatory thing actually. As a customer point of view, it is very important. But as a tester and development point of view, for us it's not much important. So it is low severity. Logo is wrong. It is low severity, but it is high priority. Okay. And there is another scenario, high severity and low priority. See this scenario. For flight operating system, flight operating website, defect in reservation functionality may be of high severity but can be low priority as it can be scheduled to release in the next cycle. Suppose is there any website we are testing it, that is flight reservation website. In the flight reservation website, so some reservation functionality is not working as expected. So that is high severity, right? Functionality is broken, that is high severity. But still, that is during in the testing phase itself, right? Maybe the developer will fix in the next build or next release. So we can give it as a low priority. Okay, functionality is working, but some the results are coming as a wrong. Suppose if I select the source and destination location, it is not listing the flights as expected. It is listing the flights between the source and destination, whatever plan we have, whatever travel plan we have decided. We have selected destination area, we have selected source area and destination area, but it is not giving the right flights. That will not affect the that will affect the functionality, but they can fix that defect in the next releases. So that is an example of high severity and the low priority. Similarly, I have give more number of examples here. Example of high priority and severity defect, and here high priority and high severity, low priority and high severity, high priority and the low severity. There are n number of examples I have given. Okay, so you just go through all these examples, you will easily understand this. Okay, I'm not going to in depth again. Everything is very clear. Okay, just you read this text, then you can understand very easily. So for interview perspective, these are all examples. Okay, if you remember one or two examples, you can easily explain this concept. So, so simple here. Low priority and the low severity. A spelling mistake is the page is not frequently navigated by users. And low priority and high severity. Application caching is some very corner case. High priority and low severity. Slight change in the logo color or spelling mistake in the company name. And high priority and high severity issue with the login functionality. So all these are examples. Okay. Now defect resolution. So in the defect reporting, a defect report contains there is one field. Let me tell you. Yeah, here. These are the defect report contents, right? In these contents, we have one field called defect resolution. We should have one field here. Abortion steps, reference, defect. So here there is be some resolution actually. Defect resolution point. That is more important. So what is defect resolution types? This is also an interview question. What is defect resolution types? Sometimes when you report a defect to the developer, he may accept the defect, or there are n number of chances. He may accept the defect or he may reject the defect because he don't feel whether that is a defect. Sometimes it is duplicated, that means the same defect you have raised twice, and sometimes it will be enhancement, Sometimes developer will expect more information regarding the defect. Sometimes it is not reproducible. Sometimes it is fixed. Sometimes as designed. So these are all defect resolution types. So this is the developer opinion. Defect resolution is basically the opinion about the developer regarding the defect which you have raised. Okay. So sometimes he feel it is a defect actually genuinely, so he will accept it. Sometimes he will reject it because your defect is not as per the expectation. And then the duplicate. So same defect you have raised already earlier. So the developer is feels it is a duplicate defect. Sometimes he will feel enhancement, not the defect. Enhancement is different. Enhancement is additional feature which we can add into the application. That is not a defect. So developer will consider that is an enhancement. Suppose whatever information you have provided to the developer, if it doesn't feel it is not enough, then he will ask for the more information, and then he will expect more information. That is need more information. And not reproducible. Suppose you have raised a defect that is reproducible in testing environment, but in the development environment it is not reproducible. It is not coming again and again. And then he will say not reproducible. And if developer is accepted, then he will give fixed. And sometimes the developer put your defect as designed. That means you will feel that is a defect, but as per the requirement it is a expected functionality. The developer says it is an expected functionality, yours says it is not expected functionality as per the requirement. So this is a simple conflict between the tester as well as the developer. Okay, so business analyst is a main person. He is a prepares the requirement document. He's a final decision is taken care by the him, whether he is expected behavior or it is not expected behavior. That decision is taken care by the business analyst whenever the conflict occurs between tester as well as a developer. Okay, these are the resolution types, defect resolution types. Okay, so what is defect resolution? Defect resolution is an opinion by the developer. The opinion by the developer. Opinion about the defect by the developer. Okay. Next one is triaging. Triaging is simple. When we will raise multiple defects, we have to triage. Triaging is nothing but just tracking. Like how many defects we have raised, how many are passed, how many have been fixed, how many are test, how many defects we have re-verified, how many defects again we reopened. Okay, after fixing the defect, still it will not work. Again, what we will do, we will reopen the defect. So all these things called as a defect triaging process. Defect reviewing, defect assessment, defect assignment, all these things comes under the defect triaging. So we have reported 10 number of defects, and how many defined number of defects have been fixed. And again, in the fixed 5 defects, only 2 are working, 3 are not working. Again, these 3 defects are reopened and again reassigned to the developer. All these things, activities called as a defect triaging process. Okay. So defect triaging process including all these steps, as I said, reviewing all the defects including rejected defects by the team, and initial assessment should be done, and prioritizing the defects based upon the inputs, and assign the defects to the correct release by product manager to the particular developer, and redirect the defects to the correct owner on the team for the further action. So all these activities should be involved during defect triaging process. Okay, so these are the few guidelines which we need to follow when you adding the severity. So understanding the concept of priority and severity well, you should be able to understand very clearly, and always assign the severity level based on the issue type, as this will affect this priority. Understand how particular scenario or test case would affect the end user. Need to consider how much time it would take to fix the defect based upon your complexity and time to verify the defect. So whenever you are giving the severity to the defect, you need to follow certain guidelines. So all these kind. So we need to keep in mind how much complex it is, how much time it will take. So all these things you need to be considered, and then you need to give the severity to the defect. So small exercise here. So I have few scenarios, and 5 scenarios I have. We have to give the severity to those scenarios. So let us give. The website performance is very slow. That is one defect. The login functionality of the website doesn't work properly. The third scenario, the GUI of the website, GUI means graphical user interface, upper look and feel of the application. So UI of the website doesn't display correctly on mobile devices. The fourth one, the website could not remember the user login session and some links doesn't work. So these are the five scenarios, five defects we found. So how and what are the severities we have to give these five, and we need to also give the justification. So let me see here. The first scenario is the website performance is very low. This is high severity because website can be accessible by multiple people. So the performance bug can cause huge inconvenience to the user. So high is severity. Second one, the login function of the website doesn't work properly. Even if login functionality itself is not working, we cannot proceed further, right? So this is completely showstopper, completely blocker. So this will be the critical severity. Next one is GUI. So the UI of the website doesn't display correctly on the mobile devices. This is a little bit medium because this is a UI related stuff. So all the UI related stuff will give the medium. So the justification is the defect affects the user who uses smartphone to view the website. Okay. So if suppose the user is wanted to see the website in the mobile phone, only that particular user will be impacted, but the users which are using on the website, they are not impacting, and 50-50%. So it is not high or critical, at the same time it is not low, so it is medium. So the fourth one is the website could not remember the user login session. Every time when you provide the usernames to the login, it will remember. When you next time when you open the page, the username and password will automatically displays. So this is a defect. So the website could not remember the user login session. So this is high. Based upon the requirement, the caching session should be there. So this is high. This is a serious issue since the user will be able to log in but not able to perform any further transaction. And some links doesn't work is nothing but low. Some links, you're not saying all the links, some links, maybe those links functionality will be implemented in the coming releases. Okay, so this is a low priority. So this is an easy fix for development guys, and the user can still access the site without these links. In that case we can give as a low severity. Okay, this is again changes. This is not fixed, based upon the situation, based upon the requirement, based upon the customer priorities, everything will be changed, right? So these are all about, so tips for good bug report. So if you want to prepare a good kind of bug report, we need to follow all these things. It should be structured, it should be able to reproduce and isolate, it is generalized, and it is comparable and summarize, condense, disambiguate and neutralize and review. So these are the need to some tips we need to follow. Test carefully. We should testing should be done very carefully, and again we need to test thrice and twice and thrice before uh, sending the bug to the developer, and test this differently. Suppose some defect will happen in your system, the same test case will execute successfully some other test, some other system. So we need to test in multiple systems or multiple environments, test it elsewhere, and does the same failure occur in other modules or locations. That is environment related stuff. So at least we need to test our 2 to 3 environments before reporting the defect to the developer, and compare, review the results of the similar tests, and summarize related tests to customers. Put a short tagline on each report. So summarizing means related test to the customer. So same kind of tests should be same functionality is working fine or not. Same kind of functionality in the some other system or some other browsers are working or not. And condense, trim unnecessary information. So we should not send unnecessary information to the developer. Some people will send huge log files to the developer. That much is not enough, that much is not required. So wherever the issue is occurred, only that particular related log file is enough. Some screenshots also we need to send to the developer. And disambiguate, use clear words. Whenever we is communicating the defect to the developer, you should be able to understand very clearly. So that's the reason we need to give each clear steps to him. And neutralize, express problem impartially. So deliver bad news gently. So even though the defect is affecting, we should communicate with diligently to the developer in proper way, in official way. Okay, so we should not fight with them. So review means be sure, that means we have to review twice or thrice before reporting the defect against the developer. So because whenever we report the developer defect, whenever we report defect to the developer, so developer feels bad by normally, because whatever they have developed, we are just identified the problem in that. Okay, so that's the reason he will feel little bit uh, different. So we need to send this defect to the developer in proper way. Okay, so we need to follow this guidelines or tips whenever we report the defects to the developer. So this is just bug life cycle process. Like I'll take another 5 minutes and let me close this. Okay, so whenever we report the bug or defect to the developer, it should go in different steps. Okay, this is called bug life cycle or defect life cycle. So defect life cycle is in the sense, whenever you report the defect, from that still the defect is closed, so whatever stages it is go on, so that is basically called as a defect life cycle. So here reported defect, so the first time it is reproducible or invalid. If it is a not reproducible, if it is an invalid defect, we have to close immediately. The developer code, this is the test or develop responsibility. If the defect is reproducible or not invalid, then assign the priority and direct to the concerned developer. Then the developer will check his defect is valid. Yes, then he needs to fix immediately. If it is not valid, then close the defect as invalid as per the design. If it is not valid, then he has to fix it and then fix the defect, or if it is no, then schedule the defect for future release. Need fix immediately, then you can uh, yes, then fix the defect, or immediately not required, then plan it for future, plan it for another build. But he is accepted as a defect. Okay, that is again priority, based upon priority, he has to fix immediately or he can fix future. And if yes, then send the validation on the new build, send for the validation on the new, he will fix the defect in the new build and then he will send the new build to the tester, and again we will validate the defect on the new build. Then again, is defect fixed or resolved, we need to verify. If it is fixed, then close the defect. If it is still not fixed, again the reject that defect, again it will come back to the initial stage, that is reopen stage. Okay, so entire stuff we can simply say in few steps. So first we open the defect, and if it is a reproducible, yes. If it is a reproducible, if it is not reproducible, close the defect. If it is reproducible, yes, and report the defect to the developer and he will fix it. He will fix it. After fix it, we need to verify and close it. If the after fixing, if it is not working, and then again reopen the defect. This is at high level, very simple way. This is bug life cycle. So in interview, people will ask you explain about bugs life cycle. You need to draw this diagram and you need to explain this. Okay. So and Jira is a tool. So as per the Jira, the defect status will be like this. So whenever we create a new defect, it will be open state. And whenever the defect is resolved by the developer, then it will be resolved state. And whenever we close the defect will be the closed state. And when developer is working on the defect, then it will be in the in progress state. So suppose developer says fixed, but it is still not fixed, then we can reopen the defect. In that case, the defect will be in the reopened state. So defect having a certain state or status: open, resolved, closed, reopened, and in progress. So these are the states of the defect as per the Jira tool. Okay, so new, open, need more info, fixed, closed, rejected, deferred, duplicate, invalid, reopen. All these are again states of the defect. That will be changed based upon the tools. As per the Jira, only we have 5 states. If you go for some other tools, you will have more number of statuses like this. Okay, so this is all the states. So now the last one is in SDLC, the last phase is closing, test cycle closure. So in the test closure, we need to evaluate so many things. So like all test cases have been executed or not, all bugs have been closed or not. So all these things we will review in the meeting. So evaluate all the completion criteria based upon the time, coverage, cost, software, all these things, and prepare test metrics based on the above parameters. Document, prepare test closure report. All these things they have done. Finally, they will decide to stop or sign off our testing based upon certain criteria. Okay, the major criteria is all test cases should be executed, completed, everything is passed, and there are no P0 and P1 defects should be there. Okay, and minimal like P3 and P4 should be there, but it is very minimal criteria. Again, this is as per the company standard. Okay, but any company should not allow P0s and P1 because these are the blockers. Okay, so this is the test life cycle, the last stage of testing STLC. This is the last stage of STLC, software testing life cycle. Okay, so I'll stop here. So today we have discussed about STLC process in detail. So test planning, test designing, test execution, bug reporting, and test flows. So these are the different activities. So during test planning, the main task is test planning, preparing the test plan document. And test designing phase, the main activity is preparing your test scenarios and test designing test cases. And the main activity during test execution is executing all your test cases based upon the priority and identifying the defects. And the defect reporting phase, the main activity is after identifying the defects, we need to report the defect to the developer by providing required information. And then defect closure. So defect closure, we need to identify all the test cases have been executed and passed or not, all the defects have been closed or not, and then we can exit from the testing. We can sign off our testing. So these are the activities or STLC process, software testing lifecycle process. So Deepa, any questions so far? So I'll stop for today here.